Hello and good afternoon. This YouTube video is going to be a tutorial on L2TPv3, and we're going to discuss some of the use cases for L2TPv3, and I'm actually going to go ahead and demonstrate with the topology that you see over here on the left. And so as you can see, I've got the L2TPv3 demo set up here in GNS3, so you can download GNS3 for free. And it's a fantastic tool to go ahead and do simulations just like this. So what this tutorial is really aiming to show you is how you can extend your layer 2. And I work with a lot of customers where, for instance, let's say that these routers here, R4 and R5, are in one building, and we're going to say that these are going to be located in New York. And then you've got routers R6 and R7, and these routers may belong to the same company, and they're located in San Diego, right? So cross country. We're going to go ahead and say that this is our internet cloud, right? So this is just simply the internet here, right? And this will be our provider edge router. We'll just use some MPLS terminology here. We're not doing MPLS, but so this will be the provider router. So this is our router, and this is our interface into the cloud, right? And same thing here. So you've got a building in New York, and you've got a building in San Diego. And let's say that you've got a subnet, and in our case, it's going to turn out to be the 192.168.1.0/24. And let's say that you wanted to provide layer 2 connectivity between R7 and R5 so that these would appear to be on the same layer 2 domain, right? Now, you're probably wondering, okay, well, there's got to be other ways to do this, and there sure are. So you could also do, if you were using the Nexus line, you could do OTV. That's another way to extend your layer 2. But this demonstration is simply going to focus on L2TPv3. I'm running all 3745s, and what iOS am I using here? I think it's 12.4. Yeah, 12.425D, as you can see here. So these are all identical routers in GNS. They're all running the same version of the Advanced Enterprise Services, 12.425D, right? And so this is what we're going to set up here. And at the end of this tutorial, what you're going to see is I'm actually going to create an EIGRP adjacency, so EIGRP adjacency between these two routers, even though there's no IP reachability from this 192.168.1.0 subnet, right? It's not going through the cloud as the 192.168.1. It's actually going through the tunnel. And let me change my color here real quick. And so, again, it's going to come through the tunnel, right? That's going to wrap all the way around and through. And that tunnel is going to provide this connectivity between those two routers. All right. So let's go ahead and get started. Let me clear the screen here real quick. We'll come back and do some more annotations. So, as you can see, I've got my configs over here for all of the routers. There may be some typos, but let's see. I went ahead and I just typed these up prior to getting started here. As you can see, all 7 routers are at the default configuration, right? They've just been wiped clean, brand new setting. So let's go ahead and get these set up right now. So I'll say no, I don't want to enter into the initial configuration. And so one of the key things we need to make sure we have, and that's IP connectivity to the loopback interfaces. And so while that's doing its thing there, so there's going to be a loopback interface here, and this is going to be loopback, and we're going to make this 44, and there's going to be a loopback here, 66, right? So I need to ensure that I've got IP connectivity between those loopback addresses, because those are going to be the addresses or the interfaces that I'm using as the local interfaces on those routers. Another key thing to remember, and this is something that I've overlooked a number of times, is that this interface here, and this is where we're going to do the Xconnect statement, basically setting up that L2TPv3 pseudo wire, that you need to make sure you have an available interface on the router. So if this was already being used for something to connect into this router, we would want to use another interface, right? You'd want to make sure you have a free interface to facilitate that tunnel connectivity, that pseudo wire connectivity. All right, so over here on router 1, let's go ahead, and first thing we're going to do is we're going to name the router R1. Okay, and then we're going to go into interface FA0/1, and this is the interface that goes from router 1 here, and if I click over here, let me go ahead and click over here, you can see you'll get a nice little output that shows you that FA01 is connected to R4 on its FA01 interface. And so we'll set up the IP addressing for router 1's FA01 interface. And we're going to say that it's 209.165.14.1, and we're going to make it /24. And then we're going to go ahead and we're going to do the no shut command, and we're going to bring that interface up. We should see some feedback here showing that it's up. All right, there it is. And now we're going to go ahead and we're going to configure FA00, which connects into R3. And so we're going to give that an IP address of 10.31.31.2, and this is going to be a /30 point-to-point interface. And then we'll bring that interface up, and we should also see that that interface is in an up status. There we go. All right. Now, you could be running any routing protocol here. You might be running BGP, right, going into a provider network. I'm just going to set this up with OSPF to facilitate the communication between the cloud and the customer router. So we're going to do router OSPF1, and we're going to put the two network statements in that we need. So the two networks we have here are 209.165.14.0, and then the wildcard mask, and those are going to be part of area 0. And then we're going to go ahead and we're going to do network 10.31.31.0, and that's going to be a wildcard mask of 0.0.0.3. We'll put that in area 0 as well. And then we're going to go ahead and end and do a write mem. So save your configuration early and often. All right, so that wraps up the configuration for router R1. And again, you can see right here are a list of the steps that if you were to type out, I could simply cut and paste these in. So let's go to R2, and we'll get this set up. And for router 2 is going to have connectivity not only to R3, but also to R6. All right, so let's get into, go from user exec into privilege exec, and then into global config. And we'll take care of the host name first for R2. And then we're going to do interface FA0/1. And so just to confirm, if I come over here and click on R2, you can see that FA01 connects to R3. So this is our FA01 here. And our FA00 is this interface that connects into R6. So FA0/1, we're going to go ahead and set that up. And let me confirm that one more time. Let's make sure we get the right interface. So 00 goes to R6, and 01 goes to R3. And so it looks like these could be backwards. So that's going to be 00 and 01. So we'll make sure our script is set up here. So for this one, we're going to go ahead and just to finish it out, since we're on int FA01, we'll do IP address 10.32.32.2. And this is again going to be a /30. And we'll bring that interface up. And then we're going to go to int FA00. And this is going to be 209.165.26.1. It's a /24. All right, so we'll do a no shut, and we'll bring that interface up on R2. And there you go, you've got your message. So we'll set up the OSPF. And this is going to have network 209.165.26.1 26.0. And it's also going to have the 10.network, 10.32.32.4, area 0. And then we're going to end, and we're going to do a write mem. All right, now on to router 3. And for router 3, we're going to confirm the interfaces, and then we're simply going to copy and paste this config. So if we click over here on router 3, so FA00 goes from R1, or is connected to R1 on port fast Ethernet 00, and then 01 goes to R2. And so that's correct. So what we can do is we can just simply grab this. We're going to get this set up here, save a little time in the tutorial. All right. And there you go. And so as you can see, if I do a show IP route, the routing table is set up with the connected routes. If I do a show IP OSPF, you can see that OSPF is running, right? Routing process OSPF1. And we haven't set the router IDs up. We're going to go ahead and pass on the router IDs as they're not really germane to this example. All right. So now we're going to jump onto router 4, and this is really where we get into the configuration work for L2TPv3. And so if you look over here, you can see, I'll go ahead and highlight, this is router 4's configuration. Okay, and so as you can see, we've got the L2TP class, we've got the pseudo wire class, and we also have an Xconnect statement. Oh, the X got taken off there. We have an Xconnect statement, so we're going to get this set up right now. So here we are on router 4. So we're going to go into global config mode. I'm going to do the hostname command, so we'll set up the hostname for router 4. And once that's done, we're going to establish connectivity FA01. And let's go ahead and confirm that, in fact, on router 4, FA01 is connected to R1, and it is. So we'll set the IP address up as a 209.165.14.2. Whoops. Forgot the address part there. Okay. And I also wanted to point out that we're going to be doing a dynamic L2TPv3 configuration here. I might do up another video tutorial that shows you how to do a manual configuration where you're setting a lot of the L2TP configuration parameters. However, for this video, this is simply just going to show you how to get it set up and how to use the dynamic L2TPv3 setup. All right, so we've got our interface set up there on R4. Now we'll do a no shut, and then I'll change over to int FA00. We'll let the message pop up. There it is. So right now, if I were to ping router 1's interface, the 209.165.14.1, all right, we've got success, so we're good there. So now let's do FA00. So I'm going to go ahead and, or actually, apologize. So FA00 is going to be our Xconnect interface. And so if I come over here, so that interface, which is fast Ethernet 00, this is our Xconnect interface. So we are not going to place an IP address configuration on there. That's the interface that we're going to use for our Xconnect statement to actually facilitate the pseudo wire connectivity, right? Or to sort of terminate the tunnel on this end. So we'll leave that guy alone for right now. All right. So back over to router 4, we're just simply going to do a no shut on that interface. And now what we're going to do is we're going to create our loopback interface. So interface loopback 44, and the IP address is going to be, whoops, is going to be 4.4.4.4 /32. Okay, so the loopback interface has now been configured, so let's exit out. And so what I'm going to do is we're going to come back to the L2TPv3 configuration piece so we can deal with that by itself. So that was router 4's configuration. So let me go ahead and save off router 4's configuration. And actually, don't let me forget to do the OSPF. So router OSPF 1, and we're going to go ahead and do network 4.4.4.4, wildcard mask of all zeros, and put that in area 0, network 209.165.14.0, and we'll go ahead and set that up. Oh, whoops, area 0. And on router 4, we're not going to be sending updates down through the fast Ethernet 00. So let's go ahead and we'll just do passive interface FA00, because that Xconnect interface, we're not going to be sending updates from OSPF down there to anything behind that. Okay, so now we're done with router 4. So if you take a quick look here, if I were to ping, or actually let's do a show IP route, and let's see what routes we've learned. So we've learned about the 10.31.31, which is this network that sits in here, right? You've got router 3 and router 2, so we haven't picked up anything here yet. So we're probably going to have to go back and take a look at that, because my guess is we're going to configure OSPF in there as well, and I may have overlooked that earlier. All right, so right now we've got connectivity there. Let's drop back and take a look at router 3. If I do a show IP OSPF, or actually let's do a show run, and we'll take a look at the OSPF section and see what we have in there. All right, so we've got the routing information there, and so we're good there. And let's take a look at router 2, show IP, or oops, show run section OSPF. Let's make sure we've got it set up everywhere it's supposed to be. So we're good there. OSPF is set up there. And then let's take a look at router 1, show run section OSPF. 209.165.14 and then the 10.31.31. So on R4, and it might have just taken a couple seconds where we're waiting, but we're still not picking up the routes from the other side, from R2 side. So we'll go ahead and we'll drive on and we'll come back and we'll troubleshoot. All right, so now let's take a look at R5's configuration. So the R5 configuration is pretty straightforward. And the key here is that the R5 router, so this is the router that we're saying we want this router, R5, to be able to have its layer 2 extended over, right? So that it tunnels through this architecture here, and that these two interfaces are going to be able to speak to each other as if they were on the same layer 2 subnet. And again, if I had hosts that were hanging off of here with 192.168s, or if this was a switch with a VLAN setup, and again with the pseudo wire, you can do it the way I'm doing it right here with just Ethernet, but you can also do it with 802.1q. So you could do it with VLANs. And unfortunately, GNS3 is not spectacular when it comes to trying to set up switching. So it's a little difficult to do inside of GNS3. I'm going to actually do a simplified config as another video where I do actually have some 3750s and some 1841s where I can set this up without as many components, obviously, but to where we're going to do the encapsulation, or I'm sorry, we're going to do the pseudo wire connect with 802.1q, right? So for VLANs. All right. So let's continue on with the video here. All right, so now we're on router 5. So the first thing we're going to take care of is we're going to name the router. And the router 5 configuration is pretty straightforward. So we're going to basically set up a default route for router 5. So IP route. And for router 5, it's going to go out the FA00 interface, right? So then we're going to go into FA00, and we're going to set up the IP address. And here's where we got our 192.168.1 dot, and we'll make this guy .1/24. And so we'll bring the interface up, and we'll save our config. All right, so on router 5, we have just configured. We've just configured that interface right there is going to be 192.168.1.1. And then we're going to do the same thing here except there it's going to be 192.168.1.254. Now I could use any available or any assignable host IP for these interfaces. I've just chosen .1 and .254, but you could make it .6 and .40 or .7 and .38. So you don't have to use .1 and .254. All right, so that interface is up on R5. Now we're going to make our way over to R6. And again, R6, this is going to be where we assign the loopback interface, because that's where we're going to have the Xconnect interface that facilitates the pseudo-wire connectivity through that network. All right, so we're on router 6. So the first thing we're going to do is we'll put the host name down for router 6. It's just R6. We're going to go ahead and go into interface FA01, and this is the Xconnect interface here on router 6. So we need to make sure that we do not assign an IP address. So that's FA01. FA01 is that interface right there. Right? Okay. So FA01, we're just going to do a no shut on that guy. And then I'm going to go into FA00. And this is the interface on router 6 that communicates up into the provider network or the cloud or the internet here. Goes up to router 2, so it's going to be IP address 209.165.26.2, and we're going to say it's a /24, and we're also going to no shut it, and then we're going to do our loopback 66. So the address is just going to be 6.6.6.6. Make it a /32. Right, and so that interface is up. Now you can also see over here we've got a bunch of the L2TPv3 configuration information, but we're going to hold on that right now. I'm going to get OSPF up here, so we'll go router OSPF1, and let's advertise the two networks that we're aware of. The 6 network, and let's also advertise the 209.165, start up the OSPF process on these interfaces. 209.165.26.0. All right, and the same thing, we can do the passive interface command on FA00 because we don't want OSPF updates being flushed out that interface for any reason. Okay, so we've got the OSPF piece done, so let's type in, let's save our configuration, and then let's take a quick look at our routing table. So let's see if we see any networks yet. So not much yet, right? We haven't learned anything through OSPF. No updates coming through yet. So can I ping 4.4.4.4? Let's see if I can ping across to the 4.4.4.4. Now, if you're an experienced network engineer, you're probably looking at this saying, yeah, that's not going to happen. And you're correct, it won't, because we haven't learned about that route yet. So if I do a ping again, we've got nothing. If I come over here to R4, if I do a show IP route, okay, you can see I know about the directly connected networks, the 209.165.14, and I know about the 4.4.4.4 directly connected subnet, which is my loopback, but I can't ping across to 6.6.6.6. And so this is going to be a problem. One of the requirements for L2TPv3 is the two routers where I have my Xconnect interfaces. These loopback addresses, there must be IP connectivity from this loopback address here, right? So from this loopback address here over to this loopback address here, I need to have IP connectivity between these two guys. And as you can see, I've got them advertised in OSPF, but we've clearly got an OSPF issue somewhere between router 6 as it comes through the cloud over here to router 4. So let's go ahead and take a look at that and see if we can figure out what that is. So we'll just walk back through real quickly what we have set up. So as you can see on router 1, I'm running the OSPF process on my 10.31.31.0 interface and the 209.165.14. So if I do a show IP interface brief, right? So those are the two networks that I know about, and I'm making that advertisement. If we check router 2, And you can see the neighbor is down on 6.6. So if I do a show IP route here, right, I don't know about 6.6.6.6. So let's do a show run and take a look at the section on OSPF. And router 2 knows about the 10.32.32.0 network, or the .4 network, I should say, because it's a /30. And excuse me, and it also knows about the 209.165.26, which is its connection out to R6. So can I ping 10.32.32.5? Aha! So this might be our problem. So I can't ping the IP address which is in this subnet. So if we go back and look at those initial configs, can I ping .6? And I can't ping .6. So if on my router I don't have this properly set up with the IP addresses, we're going to have a problem. So let's go ahead and do a show run, and let's take a look at the two interfaces that we have here. So as you can see, the IP address that's assigned here is a 10.32.32.2. However, we've got it as a /30, but that's not the network that we're advertising out. We're advertising out the .4. So what about over here on router 1 if I do a show run? And let's come take a look at the interfaces here. As you can see, it's 10.31.31.2, right? And it is a /30. So on router 3, those interfaces need to be in the same subnets. And I'll bet they're not. So fast Ethernet 01 is 10.31.32. So there's our problem right there. Our IP addressing's correct, and that's probably why I cannot ping that address. So we've got a couple things we've got to fix here. So the first thing is, let's go ahead and get into Ethernet interface fast Ethernet 01. We're going to do a no IP address, and we're going to fix this. And then we're going to say it should be 10.32.32.5. There we go. And let's see if anything happens here. Nothing yet. So that tells us we still got another issue. And my guess is it's over on router 2. Since we just looked at router 2. And you can see here it's 10.32.32.2. However, the network that we're advertising is 10.32.32.4, right? And so this fast Ethernet 01 interface from router 2 is this interface right there, because the fast Ethernet 01 interface connects to router 3. So we've got a problem here that we've got to sort out. This is definitely the network that we want to use, right, is the 10.32.32.4/30. So we're going to need to square away this IP address on fast Ethernet 01. So on router 3, it's using .5. So on router 2, we could use .6. Because .4 will be the network ID, .5 and .6 are going to be the next two assignable host IP addresses, and then .7 is going to be our broadcast address. So let's go ahead and jump in here. So we're going to go into fast Ethernet 01. And we're going to say no IP address. And so let's fix that IP right there. And now we're going to set it up as 10.32.32.6. And we should see some fireworks here once I get that set. So it shows the console has configured it. And we're going to wait and see if OSPF, whoop, there we go. So it's loading now. Jumped in the middle of my command there. So if I do a show IP route, let's see what networks we're learning about. So the adjacency has been set up. We're probably going to have to wait for the next round of updates. And sure enough, if you take a look at the differences here in the routing tables, right? So this is where I ran it before it had received updates. And all it knew about were the two connected networks. But now I'm learning about the 209.165.14. So router 2 is learning about this network here between router 4 and router 1. I'm also picking up via OSPF the 4.4.4.4 loopback interface. I know about my connected interface here, and I know about the network between R1 and R3, right? So this is good news from router 2. So let's take a look back over at router 1, and let's see what router 1 sees. As you can see there, router 1 is picking up all of its information. However, if I try to ping 6.6.6.6, which is my loopback over on R6, I'm still not having any luck. So R1 sees the 4.4, R2 sees 4.4, R3, let's see what he sees. What's he learning from OSPF? So he picks up that loopback interface, but nobody is seeing the loopback on R6. So let's take a look at R6. Oops. Let's take a look at R6. And R6 only sees its connected networks. So if I do a show run section OSPF on R6, we can see here that we've got the router OSPF 1 statement in there. Passive interface fast Ethernet 00. Let's confirm that. So R6's fast Ethernet 00 interface, as you can see, actually goes to R2. So let's sort that out. Whoops. Go into global config mode, back into our OSPF configuration, and we're going to do a no passive interface. And as soon as I do this, again, you should see some fireworks. And I'll set the passive interface on FA01, which is the right interface. That's the interface we wanted to set it on. So if I do a show IP route, as you can see, no OSPF updates yet. It's going to take a couple seconds here. And what we're going to see when it does come through is a whole lot of OSPF activity where we've picked up 4 additional routes that we've learned about. Okay, so now if I come back over to R1 and I do a show IP route, I now see the 6.6.6.6. So from R1, can I ping the loopback interface on router 6? I can. So from router 6, it should make sense that I can, I'm sorry, from router, I did that from router 1. So from router 6, let's ping 4.4.4.4. So from router 6 over to router 4, I can ping that loopback address. So from router 4, now let me try to ping over to 6.6.6.6. Works like a champ. And that is one of the major requirements for L2TPv3 is you should always use a loopback interface on the router as the local interface. And we'll see this when we do the configuration for L2TPv3. You should always use a loopback interface, and you need to make sure that there's IP reachability from each of the routers to the other router's loopback interface in order to set up L2TPv3. Okay, so we've got the OSPF set up, we've got IP connectivity set up. Let's go ahead and clear our screen here. Whoops, close that. Let's go ahead and clear the screen here, and we'll do clear the screen. So now we've got connectivity from this guy over to this guy, right? To the loopback interfaces, and that's what we need, because what we're going to do now is we're going to go ahead and set that interface up and that interface up to facilitate our tunnel connectivity so that R5 can communicate to R7 via the tunnel, even though there's no IP address information out here on the internet or locally to talk about this 192 network that's going to be down there. All right, so first we'll go ahead and we'll roll back up here to R4. And so if you take a look, here is the configuration information. Whoops. Here is the configuration information for R4, and I'm going to go ahead and I'm going to type that out by hand. So we'll go from privilege exec into global config mode. So the first thing that we're going to do is we're going to define the L2TP class. And so for router 4, we're saying again that router 4 is in New York. So I'll just call it New York v3 class. So the L2TP class name is going to be New York v3 class. As you can see, it takes me into a sub-configuration mode. And if I type a question mark, here's just a handful of the commands that you can use from this sub-menu option, the L2TP menu, right? So, and this is where you would do a lot of the manual configuration, but we're not doing manual configuration here. So we're going to set up the authentication. We want to make sure the passwords match. So the password and the 0 means it's in clear text there. It's just Cisco. And then I'm going to exit out. So now that I've created the L2TP class, define that, now I'm going to define my pseudo wire class. And we're going to call this New York pseudo wire. The encapsulation type that I'm going to use is going to be L2TPv3, because that's what we're trying to do here. The protocol that I'm going to use is going to be L2TPv3. And this is going to tie back to the New York v3 class. Now, here's the statement. This IP local interface. Now, this is the local interface that we're using. And so on router 4, we're using loopback 44, right? And so I'm going to exit out there. Okay, so I've got everything set up and ready to go. The last thing I would need to do would be to go into the interface that I'm going to use as my Xconnect interface, or my pseudo wire tunnel endpoint, right? So I'm going to wait right there, and now I'm going to step over and we're going to do the configuration on R6. Okay, so here we are on R6. We're going to go from privilege exec into global config, and let's go ahead and again define our L2TP class. And so we're out in San Diego for this example, and we're going to go ahead and say this is, oops, I apologize, San Diego v3 class. We're going to set up the authentication. The passwords have to match on either end of the pseudo wire. Let's exit out there. And so now we've defined the L2TP class, San Diego v3 class. Now let's do the pseudo wire class. So this will be San Diego pseudo wire. And again, the names of the classes, they're locally significant and do not have to match on either side of your pseudo wire tunnel. Okay. So, whoops, we didn't want to do that. So let's go back into global config, pseudo wire, San Diego pseudo wire. So now we're in the sub-menu configuration. So the encapsulation, we're going to use L2TPv3. So we've got that set up. And the protocol is going to be L2TPv3. And we're going to tie it back and associate it with the San Diego v3 class that we had just previously defined in our first step. And again, the local interface. So what is the IP address, or which interface I should say, are we going to use on this local router to terminate the pseudo wire tunnel, right? So when someone's coming in to make a connection to us, what is the local IP or the local interface going to be? So it's going to be IP local loopback, and we're going to use loopback 66, and that's why we created that. And give me a second here. I left off the interface keyword. So that is the interface we're going to be using. Again, just a local loopback, and I can't stress this enough. You always, whenever you can, you always want to use loopback interfaces for these local interfaces underneath the pseudo wire class. Okay, so we've got that in there. So now I'm going to go ahead and type N. Let's type write mem, save our config. And so what if I were to type in show L2 tunnel? So right now you can see we've got nothing active, right? So there's no tunnels on R6, and let's do end here and do a write mem, and let's do a show L2 tunnel. And if I do that command with a question mark, we do have some options, and we're going to take a look at some of these options once the tunnel is established. But as of right now, you can see nothing is active, right? Because again, we've got to configure these interfaces here, right? FA00 with the Xconnect statements that are going to go through this network, right? They're going to be looking for that loopback interface, that local IP that's going to facilitate that connectivity so that we can have connectivity between R5 and R7. So what I'm going to do right now is I'm going to configure R5, and we may have already done that, so let's take a quick look here. So if I do a show IP interface brief, All right, so fast Ethernet 00 is configured, so we're set up on R5. R7, let's go ahead and take a look. Now, we haven't done anything here, so let's go ahead and knock out R7. I'm going to copy and paste that information in. And as you can see, R5 and R7, they just simply have a default route that says just go out the interface that we've got listed there. So we'll get this, whoops, grab this real quick. So we're going to copy this. I'm going to paste it down. All right, so we're going to save our configuration there. And so the R7 interface has an IP address of 192.168.1.254. So let's see, can I ping over to 192.168.1.1? And you can see here the ping is going to run. So I'm trying to ping from this interface, which is 192.168.1.254, over to this interface. And as you would expect, we have no routing information whatsoever for the 192.168.1 network. It doesn't exist out here in our internet cloud. It certainly doesn't exist on these routers here, which are at our local prem, right, that are on our premises inside of our enterprise network facility, wherever that, New York over here on the left and San Diego over here on the right. So I've got no connectivity. And can I go from R5? Let me see if I can ping 192.168.1.254. And again, as you would expect, it's not going to work. So let me make sure here on router 5, I want to confirm that I've got the default route. Yep, gateway of last resort is 0.0.0.0, and it's out fast Ethernet 00. So we've got our default routing statements. Okay, so this is really going to be the end of the tutorial here. Is we're going to now go ahead and we're going to set up the final phase, which is going to be the Xconnect statements on routers R4 and R6 on these interfaces right here. Okay, so let's do R4s first. Again, let's show. Still, no tunnels, right? No tunnels are active. So we'll go into global config mode, and on R4, I'm going to drop down into interface fast Ethernet 00. And if I do show run int fa00, let's make sure, and that's where we want to be. So now I'm going to type in the Xconnect statement, and this is going to establish the tunnel connection between R4 and R6. And so it's going to be Xconnect, the IP address on the router where we're going to terminate this pseudo wire connection. This is going to be the virtual circuit ID, and the pseudo wire class that this should be associated with is New York pseudo wire, right? Or New York PW is what we typed in. All right, so I'm going to go ahead and type this in. I believe the interface is up. I always like to do a no shut just in case. Okay, so we're done. So now let me do write mem. Let's do show L2 tunnel. Let's see what we see over here. So as you can see, now we're getting some different output. The virtual circuit ID, and let me go ahead and show you some of the information here. So the local ID for this connection is 40305. The remote ID is 0 because right now there's nothing there. The tunnel ID is 15202. And as you can see here, we've got the virtual circuit ID of 99, and that is where we typed this in, right? So that 99 that we typed in right here, that's what shows up right here. And very important, this number must match on both sides of the pseudo wire tunnel in order for the tunnel to come up. And then again, the interface on which we executed those commands is FA00. And so this is the interface that's going to allow us to facilitate the connectivity. So this FA00, if I draw a really long line, since we just did router 4, is that interface right there. Okay? Now the state, this is very interesting here. It's just waiting for the tunnel, right? So if I run this command again, you can see it just says no tunnels. Now, we didn't set any keep alives up because L2TPv3 does the keep alives all by itself. Let me clear the screen for us. And we're going to go back to the cursor here. And again, you can see it's just waiting, right? The status is waiting. So let's go ahead and let's wrap this up. Let's establish this tunnel right now. On this side, R6 doesn't have the Xconnect statement, so it's not actively going out trying to set up that tunnel with anybody. So it's just going to say, hey, I've got no active L2F tunnels, L2TP tunnels, or PPTP tunnels, right? But let's work on that. So on router 6, we're going to come over and we're going to go to interface, fast Ethernet. I want to make sure I get this right. It's going to be fast Ethernet, and let's confirm. Pull back here real quick. Do show IP int brief, and I don't have that statement over here in my config. I just realized, so I should probably grab this and copy that, and we'll bring it down here and fill it out. And I always like to keep a notepad. You know, this is a text editor on the Mac, but I always like to keep the whole config, so in case I try to do this again and I need to pull the configs back up for any reason, or to just modify them to maybe apply them to a different scenario, I've got them right here. And so again, this won't be the New York. This is going to be San Diego. Okay, so we're good, and I believe, I'm not mistaken, it's FA01, and it is. As you can see here, it's unassigned, right? All right, so let's jump into int FA01, and now we're going to go ahead and put our Xconnect statement in here. So Xconnect, and we're going, so this is on router 6, so we're going to go over to the loopback on router 4. I want to make sure that I put in a matching virtual circuit ID, and the pseudo-wire class locally here on this router, router 6, is the San Diego pseudo-wire class that we defined a little earlier on. Okay, so when I hit enter here, we've already done the no shut. So what should happen is we should see the circuit establish. So let's take a quick peek on R4. Let's see what we've got going over here. As you can see, nothing active, and it's going to say this until the signaling protocol, or the L2TPv3 protocol, is going to try to discover some tunnels. So as you can see, there's nothing going on router 4. It's not even trying to discover. So let's come over to router 6 and quickly hit enter, end, and do a show L2 tunnel. So as you can see, it's showing shut down, and the state shows shut down. So let's take a look and let's see. We've got no active tunnels here. All right, so it's showing 4 is still shut down. So let's go back over to 4. Let's see what 4 is doing. And 4's got nothing active right now. So let's see what happens on router 4. All right, so it's trying to establish with router 6. However, it's just showing shutdown, and as you can see, it kind of dies out there, right? So back over here on router 6, we're kind of seeing the same thing, right? So then the question becomes, we've executed the Xconnect statements, right? For whatever reason, it doesn't show that the tunnel is staying alive. So can I still ping 4.4.4.4? I can. And on R4, can I ping 6.6.6.6? I can. So let's take a look at our L2TPv3 configuration. Maybe there's a typo in here somewhere. So as you can see, we've got the pseudo-wire class, New York pseudo-wire. The encapsulation type is defined. Protocol is defined. The IP local interface is going to be loopback 44, and this is on router 4. So here's our loopback, so we're good there. So here's Ethernet, or fast Ethernet 00. As you can see, the Xconnect statement goes over to the loopback on router 6. Virtual circuit ID is defined, and it's associated with the pseudo-wire New York. But what don't we have here? Are we missing anything? The OSPF is up, it's good. Right, here's our L2TP class, New York v3 class with the authentication, and that's actually Cisco, right? So everything looks good here, so let's do show L2 tunnel and see what we see. Nope, it still shows it's shut down. Let's come back over here and let's do a show run on R6. Make sure we don't have any typos in here. So the L2TP class, San Diego v3 class, we've got our authentication. Here's our pseudo wire class, right? San Diego pseudo wire. We got the encapsulation type defined. The protocol is defined for that class. And the IP local interface is loopback 66, which we have defined here, right? 6.6.6.6. And as we come up and take a look at our Xconnect statement on fast Ethernet 01, you can see that the Xconnect is going over to 4.4.4.4 with a virtual circuit ID of 99. And the pseudo wire class it's associated with is the San Diego pseudo wire. And so let's go ahead and take a look at the L2 tunnel. And as you can see, we've got nothing active, right? You can see it's trying to establish, but still nothing active. So if I do a show IP interface brief, and let's make sure that for router 6, we've got the right connections going here. So fast Ethernet 01 is definitely the interface that we want to have our Xconnect statement configured on for router 6. So if we scroll back up, you can see fast Ethernet 01. There's our Xconnect statement. And so that looks good. Let's double check on router 4. Show IP interface brief. Should be fast Ethernet 00 because that connects down to R5, and it does. Okay, so we've checked a lot of stuff here. So what we're going to do now, since this is still not working, there's definitely an issue here, right? If I do the show L2 tunnels, we've got nothing on our R4. Let's take a look at R6, right? It shows it's shutting down, so something's wrong. So here's what I'd like to do. We're going to go ahead and we're going to look at a debug, and if I remember correctly, it's going to be what are we at? Debug VPDN, and it's going to be L2X, and I think it is events. Yeah, L2X events. All right, so this is the debug command that we can use to take a look at the conversation that's taking place between R4 and R6. And let's run that same command over on R4. So debug VPDN and L2X-events. All right, so we've got the debugging on. Let's see if the debug output, and this is typically, all right, we've got some good output here. This is typically where you want to go once you get to the point where you've double-checked everything, you think that everything looks good, and so let's do a U all. So we'll stop the debugging here, and we'll see what's going on R4. Right, so nothing on R4 yet, and here it comes. Let's see what we get. That was about everything we got. So let's take a look at R6 here. So as you can see, it's going to talk about the L2 tunnel session, the L2TP tunnel session that's being set up. And right here in our debug, if you take a look, it says got a challenge from remote peer R4, got a response from remote peer R4, tunnel auth failed for R4. And it shows that it expected one string, but it got a different string. So the tunnel authentication has failed, and that's why we're seeing the tunnel go up and down. Or I shouldn't say up and down, it's really not even coming up, but we're seeing the tunnel fail, right? So it shows it's trying to establish itself, and it's not able to. And this is probably a very good indicator as to why. So let's come back over here to R4. Do a U all. We're not seeing the same output, but if we take a look through here, let's see the tunnel state change from idle to wait control reply. New tunnel created for remote R6. And then there's a stop, and the tunnel state changes to shutting down, right? And then shut down tunnel. Then shut down to idle. So got a challenge. And here it doesn't tell you that the challenge was incorrect. It just simply tells you that it's receiving a challenge. It didn't say much. So you do that debug on both sides of where you're creating your tunnel, right? And it looks like there could be an issue with the response. So is it possible that we typoed the password here when we set up our authentication between R4 and R6? Is that the challenge it could be talking about? Obviously different strings, right? But it could be because it was encrypted differently. So let's go ahead and see if we can tweak this. So we're going to go into global config mode. I'm going to drop down and see if it's going to allow me to change the password. And we're just going to make it Cisco, C-I-S-C-O. So if I do a do show run, let's see if the password encrypted out the same. So a little different. And let's go ahead and do the same thing over here. Conf T. L2TP class, we'll do password. Whoops. And actually, what I should have done was password 0 Cisco over here as well. So let's do that one more time. Password 0 Cisco. All right, and so we'll do an end and a write mem. And I'm going to do a show run again here, and let's take a look at that section. All right, so there's our authentication that's been set up. Let's take a look at our 6. Save the config, and then we're going to do a quick show run. And let's see what we've got. All right, so we've changed the passwords. We've made them the same. Let's do a show L2 tunnel and see what we get here. All right, it looks like we've got some activity here. Show L2 tunnel, right? And we've got success. So it was something wrong with the authentication that was run. I'll have to actually, I'm not sure if I typoed it or if what I did wrong there initially, but that was the problem. And again, great tutorial to be able to take a look at, hey, what happens when I have problems? What are some of the commands that I can run to figure that out? And we actually went all the way down to the low level in the weeds debug command to take a look to actually be able to see, hey, there's an authentication issue here. Because you'll notice when the tunnel was establishing, when we were doing the show L2 tunnel, we weren't seeing anything that indicated that, hey, there's an issue here with authentication. But we go in, tweak the password under the authentication, and now our state is established, right? Virtual circuit ID, and there we go, we're matched there. So the tunnel is now up. So as I said before, there's some different options that you have here. So we can take a look at the session, and I can say all. So this is going to give us a whole bunch of information about this session. Most notably, I want you to pay special attention. So we want to make sure that the traffic is going over the tunnel. So no bytes have been sent, no bytes have been received, right? And that's our status here on R6. If we come over to R4, do a show L2 tunnel session all, you can see, same thing, right? No packets sent, no packets received. Now, this is where R5 and R7 come into play, because if you remember from our previous discussion, so we've got an IP address here, which is a 192.168.1.254, and all the way over here on the other side of the country in New York, it's just a .1. So the subnet that these guys share between the two of them is 192.168.1.0/24. So have I been able to extend the layer 2 between these two locations? So let's drop in over here on R5 and let's take a look. And we'll do a show IP int brief, show IP interfaces brief. And so the interface is down, so let me go ahead and bring that interface up. FA00, we'll do a no shut. We should get a command, or I'm sorry, some feedback here. And there we go right there. The interface is changed to up. So I'm going to run an extended ping here. So if I ping, and I'm going to ping 192.168.1.254, and we're going to do it 500 times, right? And let everything run by the default. So again, I'm pinging from this router through the tunnel over to this interface here on R7. Now, pretty sure R7 is shut down, so that's why it's not working right now. But let's jump onto R7 and take a look and see what R7 sees. So if I do a show IP int brief, as you can see, it surely is shut down. So let's do conf t int fa01. And before we do the no shut, let's take a look at the statistics. Ah, sure enough, the ping packets are going through, and if you watch here, this is actually going to continue through. So 29 packets, now we're at 31 packets. So the traffic is going through the tunnel, right? The L2TPv3 tunnel. Let's see if R6 sees any traffic. Still nothing over here on the R6 side of the tunnel. And now let's go ahead and bring up the interface, save our config off, and let's see what happens on over on R5. Aha! So now it's succeeding. So take a look on R4, and that's, again, this is where the Xconnect tunnel interface is, right there. So the Xconnect tunnel interface is here, and it's also here, right, on R4 and R6. And so you can see 196 packets sent. It should be a pretty good clip now. 378, so plenty of traffic going through. Let's see what R6 sees over here. Aha, now R6 is actually starting to see traffic as well. And so that traffic is also going through the tunnel. So what if I try to ping over to 192.168.1.1? Oh, I'm sorry. So as you would expect from R6, that's not going to work, right? Because R6 doesn't have a route. It has no idea how to get to 192.168.1.1. Now, if I do what I wanted to do, which was come to R7 and run that ping, take a look at that. So as of right now, we're in great shape. We actually have connectivity. I'm going to change over to red here. Actually, we'll go to dark. So we actually have IP connectivity that goes from this interface here on R7, right? Or from this router, R7's interface, and I'm communicating now over to router R5. But the communication path, which we'll put in red, the communication path that's coming up here through the internet cloud and then down like that. So I've now effectively extended this layer 2 domain, right? The layer 2 domain has been extended over a layer 3 topology. All right? Again, keeping in mind that that is an interface, right? So I need to make sure I have an interface I can dedicate to that. And over here it is, I believe, FA01, right? And I've made that connection in. So now that there's connectivity here, and it's also connectivity on a layer 2 basis, now what I can do is I can go ahead and treat the communication between R5 and R7 as if it's on the same local subnet, right? And so the final step of this tutorial is going to be to set up an EIGRP adjacency for the 192.168.1.0 network between R5 and R7. Now keep in mind that traffic is all going to be traversing this network, right, out onto the internet here, the simulated internet we've got with those 3 routers there. But it's going to behave as if these guys are locally connected. So let's knock that out right now. So on router 7, let's go ahead and do global config mode, router EIGRP, and the ASN will be 99. We don't want any auto summary on, and we're going to do network 192.168.1.0, right? And then we'll jump over here to router R5, and we're going to go ahead and do router EIGRP 99, no auto summary, and then network 192.168.1.0. Let's see what happens. And take a look at that. We've got the neighbor change, syslog message that popped up, and the new adjacency is up. So if I do a show IP EIGRP neighbor, there it is right there. So I now have a neighbor adjacency formed between R5 and R7. And so just to review real quickly, while I've got this set up here, you might be asking yourself, well, is this an ideal type configuration? Because there's no encryption here, and you're absolutely right. So the follow-on to this tutorial that you're watching right now is going to be setting up IPSec between R6, right, which we're considering as on our local San Diego network, right? This is in our building here, and here's our, this will be the provider edge routers, and New York, right? So we're going to set up an IPSec tunnel between router 4 and router 6. That way, all of that traffic is encrypted. Because right now, L2TPv3, there is no encryption, right? And so that, as I'm sure you know, and make sure I'm spelling this right, encryption, that, as you know, is not good. No es bueno. So I'm going to do a follow-on tutorial with this exact same network setup here, this exact same, what am I trying to say? This exact same architecture, and we're going to set up IPSec between these guys so that everything is going to be encrypted, because that's what we want. Right now it's not encrypted, but again, this tutorial was just to talk to you about L2TPv3, and again, to recap, we use the dynamic L2TPv3 configuration when we did our setup. We had a great troubleshooting experience with OSPF. We got to take a look at troubleshooting all the way down to the debug command on how to see what was taking place when the L2TPv3 session was trying to establish. That actually led us to the problem, which was our passwords didn't match, or there was something wrong with the authentication. And then we were able to bring those tunnels up, and then finally you learned how to basically extend your layer 2, right? So this comes in very handy if you're doing a migration of some kind, or if you're simply trying to establish that connectivity, right, and extend your layer 2 domain from one part of the country or one part of the world to another. All right, I hope you've enjoyed this tutorial. Again, we got to look at some great stuff here. I'm using GNS3, which is free. You can download it for free, and it's a fantastic tool. All right, I hope you find this L2TPv3 tutorial helpful, and look for the follow-on tutorial, which is going to set up IPSec between our New York and our San Diego offices. That way, all of this traffic is encrypted. All right, thanks for watching, and have a great day.